scientists were shocked to find out that strange and unexpected things are happening on Neptune. Neptune is the keeper of the deep, the last known major planet from the Sun, the god of the boundless sea, beyond the inner solar system that marks the shore of the black depths of interstellar space. Neptune wasn't discovered until 1846, despite having a diameter 4 times that of Earth and being 45 billion kilometers away from us, making it appear small and even to powerful telescopes. Throughout the past 2 decades, scientists have seen dramatic changes in the planet's atmosphere, and its most recent changes have scientists worried. What's happening on Neptune, and how can this have a detrimental effect on our everyday lives? Let's find out. Neptune isn't something you hear much about, is it? Certainly not as frequently as the other planets. Images of Jupiter's clouds and Mars's surface are frequently provided by space robots. Mercury is frequently blamed for astrology enthusiasts' terrible days, even though Mercury being in retrograde is actually just an optical illusion in our night sky. The Cassini spacecraft orbited Saturn for 13 whole years before crashing into the planet, ending its illustrious run of observations. Additionally, planetary scientists have said that NASA ought to give top priority to sending a probe to Uranus in the upcoming 10 years. In fact, Neptune's brief presence in the headlines due to a new study regarding what makes Neptune so blue was unusual. Even that discovery, according to Patrick Irwin, the study's lead author and a planetary physicist at Oxford University, was unintentional. Owen claimed that his team's goal was to research the atmospheres of Neptune and Uranus, rather than to look into the specific enigma of Neptune's beautiful appearance. This is how the 2 ice giants, so named because researchers think the planets were initially glommed together from icy materials, are frequently investigated. They are roughly the same size, bigger than Earth but smaller than Jupiter and Saturn, and share a lot of other characteristics. They are planets without surfaces that have atmospheres made of hydrogen, helium, and a small amount of methane. Scientists believe that under extreme pressure deep inside these objects, diamonds are being formed when carbon atoms are compressed. Science has previously known that the methane in Neptune's and Uranus's atmospheres, which absorbs the red colors of incoming sunlight and leaves blues and greens for our eyes to view, gives them their generally bluish appearance. Owen and his associates discovered that a certain layer of methane haze on Uranus is twice as thick as it is on Neptune. Though if there were no haze, Owen claimed these atmospheres would be naturally blue. They get paler when haze is added. The scientists hypothesized that Neptune's atmosphere, which is more turbulent, is better suited to stirring up methane particles and thinning out this layer. Because of this, Neptune is the bluest planet in our solar system, while Uranus is a gentle aquamarine, making them the ideal contrast for our most underappreciated planets. Neptune should, in theory, be able to enjoy its position in the cosmic lineup as the planet that is furthest from the Sun, but everyone is still debating whether Pluto counts as a full-fledged planet or not, despite losing its position in 2006. When planetary scientists aren't arguing over that, they're looking for Planet 9, an imaginary planet that is said to orbit the Sun beyond Neptune, and whose existence could explain the odd orbits of some distant celestial planets. If NASA follows the advice of the scientific community and sends a spacecraft to Uranus in the coming years, Neptune will be the only planet the humans have yet to visit on a special mission. It wasn't until astronomers noted that Uranus, which had been discovered by telescope in 1781, was being pulled about in its orbit by the gravity of an unknown celestial body that they recognized it was there. Finally discovered in 1846, Neptune was found exactly where scientists had expected. NASA's Voyager 2 spacecraft arrived in 1989, many years and technological advancements later, zooming past Neptune and making it the last stop on a grand tour of the outer planets. We got a close-up view of a gorgeously blue globe, its moons, and its rings during the flyby. Undoubtedly, Neptune has rings, although not as beautiful as Saturn's. They do exist and were created from tiny rock and dust fragments. Since then, no spacecraft has landed on Neptune because Uranus is closer and would be easier for our space robots to reach. Planetary scientists recently recommended choosing one ice giant over the other for NASA, exploring planets that take so long to orbit the Sun. 84 years for Uranus and an incredible 165 years for Neptune presents such a challenge. Undoubtedly, A focused mission to Uranus that landed in the early 2030s would increase our knowledge of both ice giants. That, however, does not truly give Neptune its due. The final planets in the solar system have a unique history and peculiarities that are fascinating and enigmatic in and of themselves and deserving of our focused attention. A series of Hubble Space Telescope observations of the giant planet Neptune reveals that a massive dark storm raging in its northern hemisphere was moving south when it suddenly made a sharp U-turn and started moving back north. In addition, it might have given birth to a young dark storm in the process. The term ice giant refers to Neptune, which is essentially a huge ball of hydrogen and helium gas that also contains a lot of methane, ammonia, and other molecules. For historical reasons, planetary scientists still refer to these molecules as ices, even though they are gaseous. Neptune is the largest planet that is furthest from the Sun, at a distance of 4.5 billion kilometers, approximately 4 times the diameter of Earth. Scientists were shocked by the images Voyager 2 returned after passing by Neptune in 1989. It revealed a massive oval dark storm the size of Earth in the planet's southern hemisphere, the Great Dark Spot, so named because it had the fastest wind ever recorded in the solar system, with wind speeds of a staggering 2,100 kilometers per hour. But the spot was gone when Hubble observed Neptune in 1994. Poof, disappeared. There is no doubt that Neptune's storms develop over shorter periods than those on Jupiter, where the Great Red Spot has endured for centuries. For instance, a small dark patch in Neptune's southern hemisphere was discovered in the same 1994 Hubble observations. This dark spot must have formed between Voyager's flyby and the Hubble photos. Since then, Hubble has discovered several more black spots. They develop at mid-latitudes in both hemispheres and tend to move in the direction of the equator, but they face certain death if they do that. As a result of the Coriolis effect, which states that the speed of a planet's rotation varies with latitude, with a maximum at the equator and a minimum at the poles, air flowing outward from a large high-pressure system or inward toward a low-pressure one will cause the system to begin rotating as it meets air moving at different speeds to the north and south. As these Neptunian storms move in that direction, the Coriolis influence weakens closer to the equator, which causes them to fragment. The majority of these storms appear to end up there, but not this time. In September 2018, Hubble observed a mysterious storm in Neptune's northern hemisphere. The entire continental United States could easily fit inside this enormous, over 7,000 kilometers wide object, which was seen to be traveling south. However, inspections made in January 2020 revealed that the storm's southern movement had been reversed and was now once more headed north. Neptune is a mystery to scientists who study it, but there's more. This storm has been linked to 2 further strange occurrences. One is that it seemed to have created a smaller dark storm at the time it changed its mind and began moving north again. This is predicted to occur by some computer simulations of Neptune's atmosphere, particularly as a large storm begins to dissipate towards the equator when it can drop smaller vortices. Although it wasn't directly observed since the observation was spaced too far apart, it's possible that this is what happened in this instance. It may have shifted course due to that, according to certain theories. Strangely, like almost every other dark storm, this one doesn't have bright white clouds circling its edges. These methane ice crystal clouds are highly reflective and appear white in photographs. Winds carry methane gas up the slopes of the dark storm's high-pressure system, which resembles a mountain of air in the atmosphere. Here, the methane cools and crystallizes into ice, orographic clouds, which occur when water air pushes up the side of a mountain, cools, and condenses to create clouds typical on Earth. Images from 2019 showed the Neptunian white clouds, but they vanished at the beginning of this year. The strange behavior of the black storm might be related to this, or maybe not. Due to its distance, Neptune is challenging to observe and comprehend, and despite its enormous size, it still appears very small in our telescopes. Additionally, it is challenging to understand what's happening there due to the atmosphere's rapid changes. Neptune also has Triton, a planet-sized world with a smooth, icy surface that was stolen from a nearby region millions of years ago. Triton is one of the most fascinating moons in the solar system. As was previously mentioned, Voyager 2 sent back its sole close-up image to us in 1989, but this year, the James Webb Space Telescope focused on the far-off planet, sending back some of the best images of its moons and rings that we've seen in the past 30 years. Methane, ammonia, and water are among the several chemicals found inside Neptune. However, because methane also absorbs infrared light, Neptune appears relatively faint in JWST images. Methane is very good at absorbing red light, giving the planet an eyepiece appearance of a rich blue. It does, however, have methane ice clouds at high altitudes, which, in contrast to the gaseous form, are highly reflective and appear bright. Similar to storms on Jupiter, they appear at various latitudes above the deeper cloud deck. Neptune has several rings, just like the other 3 giant planets. These rings are probably made of ice particles that have been covered in different molecules that give them a reddish appearance. This makes them brighter in infrared wavelengths and makes them visible in the JWST image. You can also see Neptune orbiting a dozen minor moons. Proteus is a little over 400 kilometers in diameter, while most are small and irregularly shaped, measuring under 200 kilometers in width. As you can see, several of them are superimposed on the rings. These are known as shepherd moons because it is suspected that their gravity may help to condense the adjacent ring particles into little bands. What about that stunning teal star? Actually, that's Triton, mentioned earlier, the biggest moon of Neptune at 2,700 kilometers wide. It is slightly wider than our own moon but larger than Pluto. The lines running through it are diffraction spikes, which are produced when light bends around the 3 legs holding the secondary mirror of the JWST together, as well as the hexagonal shape of its component mirrors. It appears bright because it is covered in frozen nitrogen, which is highly reflective. Larger sources, such as Neptune, also have them, but they are smeared out and appear much fainter, making them difficult to see. Only when the light source is very small in an image, what astronomers refer to as a point source, can you get them this obvious. Triton is an oddball. It orbits Neptune backward in relation to the planet's rotation, leading astronomers to hypothesize that it might be a sizable Kuiper belt object that was long ago drawn in by the planet's gravity. It's challenging to accomplish this, and the precise method in this instance is unknown. In this up-close view of Neptune, the clouds and rings are more clearly visible, along with some of their fainter rings. It's interesting to see that a very thin, faint line circles the planet only around its equator. The circulation in Neptune's atmosphere moves from the poles towards the equator, where the gases sink and warm up, making it very dissimilar to our atmosphere. This weak arc might be warmer gas that is heating up and emitting infrared light. Neptune and Triton may be seen in this breathtaking wide-angle view once more, but this time, practically everything else in the picture is a background galaxy that is hundreds of millions or possibly billions of light-years away. It serves as a poetic reminder that Neptune is the solar system's final major colony. Since an orbiter could spend years first at Uranus before moving on to orbit Neptune, scientists are very interested in developing a mission specifically designed to explore the outer planets. Sending a probe that stays on a planet for a long time is the best way to learn about it, as we discovered with Cassini at Saturn. Features come and go, conditions shift, and perhaps most significantly, when researchers uncover novel occurrences, they may direct the spacecraft to investigate more closely. While learning new things is crucial, a focused objective allows you to remain and possibly ascertain their origin. We also learned that lesson from the Voyager flyby. Seeing Neptune up close for the first time allowed for discoveries like the dark storms, but if we want to understand them, we need to go there again and again. So, are we ever going to Neptune? Obviously not with astronauts, but rather with a spacecraft created exclusively to investigate the mysteries of our 8th planet. The James Webb Space Telescope, the most recent space observatory in existence, is currently watching the ice giant and should produce further previously unobtainable information about the makeup of its atmosphere. However, it's not the same as actually being in orbit. By that standard, we have no knowledge of Neptune and probably never will. A recent mission plan for an orbiter to Neptune called for an initial launch in 2033 and an arrival in 2049. However, traveling to Uranus first would mean delaying the timescale by at least 10 years. The bluest planet might not get a spacecraft companion until well into the 2050s. The challenges of exploring Neptune go beyond just its immense distance from Earth. Neptune's atmosphere is both dynamic and complex, characterized by extreme winds and unusual storm patterns. The planet's weather systems operate on a scale far different from those on Earth, making predictions and observations particularly difficult. For example, the dark spots observed in Neptune's atmosphere are akin to Earth's cyclones but can appear and vanish in a matter of months. Their behavior defies the patterns seen on other planets, suggesting a unique set of atmospheric dynamics at play. Additionally, Neptune's internal structure remains largely unknown. The planet's core is thought to be composed of a mix of rock and ice, surrounded by a thick mantle of water, ammonia, and methane ices. The exact composition and state of these materials under the extreme pressures and temperatures found within Neptune are still subjects of active research. This uncertainty extends to Neptune's magnetic field, which is tilted relative to its rotational axis and significantly offset from the planet's center. This misalignment hints at a complex internal dynamo mechanism driving its magnetosphere, but its exact nature is still not fully understood. Triton, Neptune's largest moon, is another point of intrigue. It exhibits geysers that shoot nitrogen gas into space, indicating geothermal activity beneath its icy surface. These eruptions contribute to Neptune's faint, diffuse ring system, as the expelled material from Triton settles into orbit around the planet. Studying Triton could provide insights into the geological processes that might also affect Neptune, making it a key target for future missions. Finally, the observational data from the James Webb Space Telescope represents a significant leap forward in our ability to study Neptune from afar. The telescope's advanced infrared capabilities allow scientists to peer through the planet's thick atmosphere and capture detailed images of its weather patterns, ring system, and moons. However, to fully comprehend the mysteries of Neptune and its environment, a dedicated mission capable of in-depth, long-term exploration will be crucial. Until such a mission is realized, much of Neptune's secrets will remain tantalizingly out of reach.